All right, so question number 1 on the pretest. We have here a system of equations. This is equation number 1, y is equal to negative 1/2 x minus 14.5. And we have equation number 2 over here, which is y is equal to 4 over 5x plus 18. And you'll remember from the steps for solving algebraically that there are basically only a few steps, and the first of them is to make sure that the y is isolated in both of those equations. And as you can see, that's already been done. Now, the only thing that might bother you about these two particular equations is that the a's are represented as as fractions, and you're going to probably want to go ahead and change those into decimals. So we'll do that over here. This is going to be equal to y is equal to negative 0.5x minus 14.5. And over here we'll have y is equal to 0.8x plus 18. I got those decimals just by dividing those fractions, which I didn't show on the calculator, but I'm pretty sure you guys can figure that out by this point. So once the first step is done and the y's are isolated and we have everything with decimals, we can go ahead and we do the second step. And the second step says take the ax plus b component of the first equation once it's isolated and take the second ax plus b from the other line and make them equal to each other. So negative 0.5x minus 14.5 will be equal to 0.8x plus 18. So we've taken the right-hand side of both equations once the i's isolated and made them equal to each other. Excuse me. So now we want to solve for x. We want to get the x's on the left, so I'm going to go ahead and get rid of this x on the right, and I'll do that by subtracting it. And whatever I do to the right-hand side of the equation, I will do to the left-hand side of the equation. And now I'm going to simplify. So I've got a 0.5 negative x, and I'm going to have to subtract 0.8x from that, which gives me negative 1.3x once I simplified those terms. It's gone away over here, which is what I wanted. And we write out the rest of the equation with what was left over. And now it's getting simpler. I got to go ahead now and get rid of this 14.5, which is being subtracted, and so I'll do the opposite operation. And that's going to leave me with negative 1.3x is equal to 18 plus 14.5, which is 32.5. Now I'm going to divide both sides. Right, that's a multiplication. I want the x isolated, so I'm going to divide both sides by negative 1.3. Don't forget your negative. So your final answer here should be a negative. There's my 32.5 already, and I'm going to divide that by 1.3 negative. I get negative 25 from my x. So that's the x point, the x part of the coordinate. Now I need the y part of the coordinate. And to get the y part of the coordinate, we just take that x that we found and we plug it into either of these two equations. Doesn't matter which one. I'll use the first one. Y is equal to negative 0.5x minus 14.5. And now I rewrite it with the substitution. So negative 0.5, my x is negative 25 minus the 14.5. And when I do this over here, I'm going to get a positive number for this part. I'm going to get y is equal to, clear, 0.5, which is negative, times 25, which is also negative. That's going to be equal to positive 12.5. And I still have to subtract the 14.5 from that. So 12.5 minus 14.5 leaves me with negative 2. So there's your answer. Now, one of the things I ask students to do all the time is to go ahead and verify in the second equation. So if you plug that negative 25 into the first equation and you get negative 2, when you plug it into the second equation, you should also get negative 2 for the y, because the x's and the y's are the same at that one particular location. Now I'm out of room a little bit here, but bear with me. 0.8x plus 18 is the original equation over here, and that x is going to become a negative 25. So y is equal to 0.8 times negative 25 plus 18. Sorry, it's a little squash there. Get my calculator. 0.8 times negative 25 is equal to negative 20 plus 18 And look, there it is. Y is negative 2. So I found x here, I found y here, and I verified it with the second equation. The second you get that correct in both, the same in both, you know you're right. You know that you haven't made any mistakes. And there's your number 1.